Auntie. Auntie,
What's up, hemoglobin?
I'm a protein, aren't I?
Yes, you are. Why?
Collagen said I was bought from garbage can because I look very different from him.
No, you're not. This is why it's important to learn about protein and its structure. Come, I will teach you. First, there are these small blocks that are needed to build the protein structure, and it's called amino acids.
Amino acids?
Yes, you're right. They are like puzzle pieces. You need more than one puzzle to play, won't you? When two amino acids are linked, they form a molecule called dipeptide. And a molecule made with multiple amino acids is called polypeptide.
But what is a peptide?
If you see the structure of the amino acids, it has a carbon atom in the center followed by an amine group, carboxylic acid group, and hydrogen and R group. When two or more amino acids combine together, they form a link between the carbon atom and nitrogen atom, and this is known as the peptide bond. The long chain of amino acids make the primary structure of the protein. Do you know these long chains can move and bend and have an effect on each other? Two ways in which these chains can form the secondary structure. One, alpha helix. The chains are often formed into the corkscrew shape. The hydrogen bond between the imidazine and carbon monoxide holds the shape firmly. Another is the beta pleated sheet. In this shape, the chain is much flatter and straighter than alpha helix. In tertiary structure, a combination of alpha helix and beta pleated sheets completes and forms a beautiful 3D looking structure. Four ways in which this structure can form. You can remember it with a mnemonic that goes by Happy Dogs in Heaven. The H in happy stands for hydrogen bonds. It forms between the R groups. The bond is generally weak in isolation, but strong when there are multiple hydrogen bonds together. The D in dogs stand for disulfide bond. It forms between the cysteine amino acids where the hydrogen atom in the molecules are excluded. In the in stands for ionic bond that forms between the NH3 plus and COO minus. And finally, hydrophobic. The nonpolar and water-hating molecules stay together due to repulsion of watery environment. Here we come to the last structure of the protein, the quaternary structure. This structure is a combination of multiple tertiary structures. Hemoglobin and collagen are examples of this kind. If we look into the differences, hemoglobin is like a round bouncy ball. The hydrophobic R group stays away from the water, and the hydrophilic R group stays outward, forming a globular structure. It consists of all alpha helix structure. It is soluble and contains ion elements which react with oxygen, so oxygen can be transported to the entire body. On the other hand, collagen is like a stretchy piece of spaghetti. The chains are in the helix shapes, but they are not alpha helix as it is not tightly wound. The strands wrap around each other, forming a triple helix. They are held together by hydrogen bonds, covalent bonds, and almost every third amino acid in each polypeptide is a small amino acid known as glycine, which allows strands to lie close to each other. The triple helix collagen interacts with other collagen molecules running parallel to it and forms cross-linked covalent bonds between the R groups, but they do not line up in the same position. These collagen fibrils side by side then make up a collagen fiber. Now we do know the difference between the hemoglobin and collagen, and hemoglobin is indeed a part of the protein family and was not bought from the garbage can. Now let's quickly summarize the entire video. First, we require amino acids. These are like puzzle pieces. They join together and form a long chain molecule in the primary structure. And these long chain molecule and then form alpha helix structure and beta pleated sheet in the secondary structure. In tertiary structure, the combination of alpha helix and beta pleated sheets completes a beautiful looking 3D looking structure. We also learned a mnemonic that goes by Happy Dogs in Heaven. The H in happy stands for hydrogen bond. The D in dog stands for disulfide. The I in stands for ionic bond, and H in heaven stands for hydrophobic bond. We also learned about quaternary structure. This is just a combination of multiple tertiary structure. And we also learned about the difference between the hemoglobin and collagen molecules. And this is your Paneer Auntie, and I will come back later. Thank you. Bye bye.